Okay, so here's an example. We have two sets of data, one from one neighborhood and another from another neighborhood. And the developers chose some random houses, and we want to see if the two sets of data for the two houses are the same. Assume that the data comes from a normally distributed sample, and you're to complete parts A through C. Part A is asking us to test the null hypothesis at alpha is 0.05 using the pool t-test. So what we want to know if they're equal, which is really what the assumption is. So definitely the difference is going to be 0. So it's going to be that part is correct, that is correct, that is correct. This one is definitely out, so D is out. And then the next one, we just want to know if they're different. So we're not looking for any particular direction of that difference. So the answer is going to be B. All right. Alright, so we are asked to compute the t statistic. Let the difference sample means be y1 minus y2. We're going to be using my StatsCrunch for that. So let's go ahead and bring StatsCrunch in. Stats, click on t statistic. It's a two sample test, and we do have the summary. So we are going to be entering the data. It's asking for the mean, the standard deviation, the sample size, and we enter that for both sets of data. And if you want to jump a little bit ahead, and you want to make sure the hypothesis test is what it is supposed to say, and you hit compute, and then it spits out the t statistic and the p-value. So going back to the problem is asking us to look for the t statistic. So we type 7.304 in 04, and it's going to round that 5 up to 6. And you have to be careful with those, because that's going to make you get one attempt wrong. So you absolutely want to be careful if you're rounding stuff off, that you're doing it accurately. Otherwise you will miss a chance when you really would have had the correct answer. So be careful with that. The p-value, and this is a case where the p-value given from StatsCrunch is less than 0.001. How do you enter that? Let's go ahead and try. If we enter 0.001, I think it's going to give us an incorrect result. There we go. So it's telling us what we need to do. And let's try entering just 0, because the value is so small. If it goes to less than 4 decimal places, then it's actually 0. So that's correct. It's asking us to draw some conclusions. Now because the p-value is extremely low, way lower than alpha, we are going to reject the null hypothesis. There is sufficient evidence to reject the claim that the mean average of the houses is the same for the two. And the last part of the question is asking us for the confidence interval. Going back to StatsCrunch, and then it allows you to hit, once you have the data there, you hit an option, edit, and then you go, instead of asking it to give you the hypothesis, you scroll down, ask for confidence interval, and then it spits out the lower limit and the upper limit for the confidence interval. Alright, so let's plug those values back in. And again, you want to be careful to look at the number decimal places you're asked for and make sure you're doing that accurately to not miss a chance to do something that you've done correctly. So that's the two confidence. So we are being asked a 95% confidence interval for the mean difference in ages of houses in the two neighborhoods was 9.72 to 17.08. Is this result different than the result of the pooled t-test? T-confidence interval, explain why or why not. Choose the correct response. It's definitely not very different, not significantly different, and that is because the standard deviations are fairly close and the two methods will result in essentially the same confidence interval and hypothesis test. Alright, thank you.